Hello everyone, thanks for stopping by our poster today. I'll be presenting MorphWorld, a state transition simulator. This is primarily an undergraduate research project conducted by Matthew Shan and advised by myself, Jared Moore, as well as Anthony Clark remotely, who's at Pomona College. And the simulator was built off of an idea that Anthony and I have had over the last few years where we've been interested in the sort of mode boundaries and decision boundaries in a control system for, say, a robot or a cyber-physical system. And that is, how do you decide to change your operating mode? So for instance, in a legged animat, you might have walking, trotting, and running as three possible behaviors. How does a controller, such as an artificial neural network, identify the conditions to transition between walking and running? We see this all the time in natural organisms, but it's a bit of an interesting control problem. So we've looked at it in legged systems with physical simulators and artificial neural network controllers and many degrees of freedom in the joints, but it becomes a fairly complex problem to isolate if the controller is switching modes based on a mode boundary or if it's just something internal to the robot itself. And so we had an idea to step back and maybe create a simulator that simplified the problem so that we could clearly delineate state transitions and hope to elicit more information about how the controllers make these decisions. And so MorphWorld was born. Now, MorphWorld is a three-dimensional voxelized world. So you'll see this grid here on the floor, and that indicates a cell. So you can imagine a square here projected up into a cube, and we have, I think it's 10 or maybe 11 cells wide here. So 11 by 11, and then can be any number long. And so basically it creates this long tunnel. We've got our animat in blue, and the sensors on the animat are in red. These red rays here, unfortunately, same color as our obstacles. So our obstacles are these red cuboids here as well. And the goal for this animat in this basic simulation is to navigate this maze. Now you'll notice that the gaps are different as it goes through this. In fact, here is a gap under the box versus the straight column that we have here. And so a basic controller's task is to sense objects in front of it, locate a gap. It may have to change shape. So we've got 5 different states, which are proxies for our operating modes in this simulator. We've got a 3x3, we've got a 2x5, and then it goes down to a 1x9. And the sensors move as the morphology changes, but you can see here different configurations based on the type of gaps that the robot must traverse. So we'll jump out of the slideshow, and I think the best way to show it is just to see the simulator in action. So here we've got a hand-built controller. This isn't evolved or anything, just a very simple state machine traversing the maze. And so you'll notice that it stays in the same morphology until it detects an obstacle, and then it goes into a very simple state search in this case. Now, again, in this work, we're not actually identifying mode boundaries or that. This is solely based on the simulator. So this simulator is basically coded up as a 3D list in Python, allows it to be very lightweight. The collision handling is no different than just checking certain values in the list, so there's not an underlying physics engine running, which might complexify the runtime. The project itself is available on GitHub. You can find a link on our poster if you're interested in looking at the project or extending it. And as this animat navigates the maze, I'll sign off. Hopefully you'll stop by and ask questions if you have any. Otherwise, have a great day. Thanks.